Okay, so in this problem, we're going to look again and see what type of angles that we have. And so I have two straight lines intersecting each other, and the angles that I'm looking at are across from each other on these two straight lines. So these are going to be vertical angles. So these are vertical angles, and vertical angles are the same. So I'm going to just set these equal to each other. So over here, I'm going to go ahead 3x minus 2, and this is going to equal 4x minus 10. It's easier, right? We want to get our x's on one side and our numbers on the other. It's easier to move the smaller x over. So I'm going to subtract 3x from both sides. That leaves me with a negative 2 here. 4x minus 3x is going to be 1x, and then minus 10. And then from here, I need to get this over to the other side, so I'm going to add 10. And so negative 2 plus 10 is going to be positive 8, so 8 equals x. That's how I would solve that one. And then going to the last example, we have this problem here. So again, I need to determine what type of angles that these are. I see the right angle measurement right here, so I know that this whole thing is going to be 90 degrees. These are complementary. Right? These are complementary angles, and that means that these are going to add up to equal the 90 degrees. So I'm going to just take that 50 degrees plus 2x plus 5, and that's going to equal 90 degrees. So I'm just taking the 50 degrees and the 2x plus 5 and add like terms that I can combine. So the 50 and the 5 don't have an x, so I'm going to those. So I have 55 plus 2x equals 90. And now I'm going to start solving for x. So I'm going to subtract 55. And so when I do that, I have 2x left over here, and this is going to be 35. And then once I have this, I'm going to divide by 2. So x is going to equal 35 divided by 2, or I can write that as 17.5.